Here we'll start centrifugal pump, the first problem. If you read the problem, you'll be able to make out what they have asked is vane angle at outlet, at inlet, that is theta is asked. Work done by the impeller on water per second, that is work done by the impeller. Manometric efficiency, these are the things asked. And if you go on reading, we'll be coming to know that the outlet diameter, you can see here, this is outlet diameter, is given to be 0.5 meter, and inlet diameter is half the outlet diameter. The rotational speed is 1000 rpm, h is 40 meters, velocity of flow is 2.5 meter per second. It is said that it is constant, that is Vf1 is equal to Vf2. Angle of vane at the outlet is 40 degrees, it is given. So same data I have rewritten here. So straight away with the data, what we can calculate is U2, that is pi d2n by 60. This is 26.18. U1 becomes half of that. Then Vf2 is given. Because of that, I can draw directly outlet velocity triangle, because angle phi is also given. So this becomes Vr2, this becomes U2, this becomes V2. So this is given 2.5. Then work done by the impeller is given by Vw2 U2 by G. So this calculation, for this calculation we need to calculate Vw2, that is this much of distance, the component of V2 in this direction. We'll see further. Tan phi, tangent of phi can be written. This is 2.5. We can calculate this. I have denoted as x. X is 2.98. So if we subtract 2.98 from 26.18, we'll be getting this component. So Vw2 is 26.18 minus this. So Vw2 becomes 23.2. Now using this equation, you can calculate work done by the impeller, 61.91 meters. Now for manometric efficiency, it is given by H divided by work done by the impeller. So H is, anyway they have given it is 40 meters. So 40 divided by work done by the impeller gives you manometric efficiency as 64.6. One more thing that they have asked is theta. Now if you draw inlet velocity triangle, U1 is already calculated, it is put here. Vf1 is given 2.5. Radial outflow we can assume as discussed. So inlet velocity triangle becomes like this. So this theta is to be found, knowing this has 2.5, this has 13.09. It's simple trigonometric expression. So theta becomes 10.81 degrees. Okay, there is one more problem here. Here the discharge is given, RPM is given, head, manometric head is 23, D2 is given, B is given, phi is asked, angle of outlet is asked, manometric efficiency is given. So with the data given, U equal to pi dn by 60, if we calculate, this is 18.98, and manometric efficiency is Vw2 U2 divided by G. So this becomes, this gives you Vw2 as 15.85, and then this is outlet velocity triangle, which gives you all the parameter that we have calculated can be put here. And then discharge is given by pi dB into Vf. So we can just see here, with this we'll be able to calculate velocity of flow, 18.08. That is, this distance is now found. Now tan phi is equal to Vf2, that is this minus this, This is nothing but 18.98 minus 15.85. So that gives the angle phi as 80.97 degrees. Three-stage centrifugal pump. They have said it is three-stage. Need not worry, you do all the calculations in a usual fashion. Whatever power that is developed is there, that will be of a single impeller. Now if you want a three-stage pump, you have to multiply by 3. That is the only change. Otherwise all other calculations are exactly similar to earlier discussion. So this is the last problem wherein minimum starting speed is asked. The data says that D1, D2, VF2, phi manometric efficiency. So for n minimum we need, these are the parameters which are required. There is one more equation, but with a given parameters, the equation that we can use is this one. If you look at, we need all these manometric efficiencies given, VW2, D2. VW2 is the major thing that we should be able to calculate. This is the one. So outlet velocity triangle. So U2 is equal to pi d n by 60. N will be 59.41 VW2 because in this equation we know everything else VW2, because of that I have kept calculating all the numerical things. N minimum comes out to be 59.41 VW2. This I have used as N here, pi d n by 60. So U2 also comes in terms of VW2. So V2 comes in terms of VW2, but U2 minus 2 will be equal to VW2. What is to be cared here is this angle phi is given as 45 degrees. This is 2, that's why this is 2. So U2 minus VW2 becomes when calculating VW2, we'll be able to get 2.308. 2 minus 2, this one should be equal to VW2. So if you simplify, you will be getting VW2. Once you know this, resubstitute into this equation, we will be getting N minimum. So we'll stop here.